In this video, we will use desmos.com online calculator to work with the z distribution, which is the normal distribution, and the t distribution, which is the student t distribution. When constructing the confidence interval, we will need the critical value. If the distribution is normal, we would need the z critical value. To find the critical z value using Desmos, we simply use the z critical values calculator. We will need to specify the confidence interval. The confidence interval is the area between. And so with this shaded region, if we're looking for a 95% confidence interval, all we need to do is to input 0.95, and the calculator will give us the corresponding positive critical value. The right 1.96, the left negative 1.96 by symmetry. Suppose we want to construct a 99% confidence interval, we would input 0.99 in decimal, and the calculator will give us the, again, positive critical value 2.576. The number on the left is therefore negative 2.576. Similarly, for an 80% confidence interval, we would input 0.80, and again the calculator will give us the critical value 1.282. With the student t distribution, or simply t critical value, we will need to specify the degree of freedom. And if we were to use this calculator, it will ask for the sample size. Remember that the degree of freedom is 1 less than the sample size, but in this case, we only need to specify the sample size. And so, suppose we have a sample size of 70 and we want a 95% confidence interval, we would input the sample size 70, we'll give a degree of freedom 69, and the confidence interval 95%, then the corresponding critical t value is 1.99, round to 2 decimal places. If we round to 3 decimal places, in this case, we will get 1.995. With the student t distribution, with the same confidence level, in this case 0.95, if we have a different sample size, we will not get the same critical value t. So for example, if our sample size is 50, then this time, with the same confidence level 95%, the critical value t is 2.01, rounded to 2 decimal places. And similarly, if we have the same confidence level 95%, but the sample size is 100, then our critical t value is 1.98. Now suppose we want a 90% confidence interval and our sample size is 11, then we would have a critical value t of 1.81. And lastly, if we want a 95% confidence level, we would input 0.95, and if we have the sample size 11, then the critical value t is 2.23, rounded to 2 decimal places. We just show how to compute the critical value for a normal z, critical z, and a t distribution t. If we are looking for the probability using Desmos, with the normal distribution, we would specify the mean and the standard deviation, and we would input the left and the right end points of the shaded region. With the t distribution, we would need to specify the degree of freedom, and we would input the test statistics.